Welcome to Elevate Learn. Today we're diving into one of the most powerful and elegant drag-and-drop solutions for React developers, dnd-kit. Whether you're building a task management app, a Kanban board, here's what we're covering in this video. First, we'll explore what dnd-kit is and why it's become the preferred choice for React developers. Then we'll break down the core concepts that make drag-and-drop work. You'll see how to set up your project and build your first sortable list. We'll explore working with multiple containers, look at a real-world Kanban board example, and discuss optimization strategies. Finally, we'll highlight common mistakes and how to avoid them. Each topic builds on the previous one, so stick around for the complete picture. dnd-kit stands for Drag and Drop Kit, and it's a modern, headless drag-and-drop library designed specifically for React. Unlike older libraries that impose DOM structure or styling, dnd-kit gives you complete control over your markup and styles. It's headless, meaning it provides logic and hooks without dictating your UI. The library is incredibly lightweight. No jQuery dependencies, no massive polyfills. What makes it special is the sensor system. Built-in support for mouse, touch, and keyboard interactions. It's also fully accessible, following WCAG guidelines so everyone can interact with your draggable elements. And it performs beautifully at 60 frames per second thanks to CSS transforms instead of reflows. dnd-kit revolves around a few key concepts you need to understand. First, dnd-context is a React context provider that wraps your entire drag-and-drop area. It manages global drag state and coordinates between draggable and droppable elements. Sensors are plugins that detect when a user initiates a drag. There are default sensors for mouse, touch, and keyboard. The active item is what's currently being dragged, and over refers to what's under the cursor. Collision detection is the algorithm that figures out which drop zones are valid targets. Finally, announcements provide screen reader feedback, making your interface accessible to everyone. Understanding these building blocks is essential for mastering dnd-kit. In dnd-kit, there are two fundamental types of elements: draggables and droppables. Draggables are items users can pick up and move. Think tasks in a list or cards in a board. Droppables are the zones where draggables can land, containers, lists, or columns. You'll use the useDraggable hook to add drag functionality to elements, and useDroppable to create drop targets. These hooks give you everything you need: event listeners, styling state, and transform information. Data attributes let you associate items with their containers, which is crucial for multi-container scenarios. Transform feedback through isDragging and isOver properties lets you provide real-time visual feedback to users. Together, these create the complete drag-and-drop experience. Let's start by setting up dnd-kit in a React project. First, install the core package and utilities from npm. Then, import dnd-context from the core module. This is your context provider. Import mouse sensor to handle drag detection. In your component, use the useSensor hook to initialize the mouse sensor. Wrap your app in dnd-context and pass the sensor's array. That's it. You now have a functional drag-and-drop environment. The dnd-context manages all state and communication between draggable and droppable elements. In the following slides, we'll add actual draggable items and drop zones. After running the setup code, you should see successful package installations and no errors. The dnd-context is now initialized and actively listening for drag interactions through the mouse sensor. Your application is ready to accept draggable and droppable components as children. The context provider establishes a communication layer where all drag-and-drop events flow through. If you see any errors at this stage, it's usually a missing dependency or import issue. Double-check your package.json and make sure both at dnd-kit/core and at dnd-kit/utilities are installed. Now that the foundation is set, we're ready to add actual interactive elements. Now let's create a draggable item component. We'll use the useDraggable hook, which is the heart of making elements draggable. This hook returns several properties: attributes for accessibility, listeners for event handlers, setNodeRef to register the DOM node, transform for animation, and isDragging to know when the item is being dragged. We apply the transform using CSS. Translate dot to string to smoothly animate the element's position. The isDragging state lets us provide visual feedback. Here we reduce opacity to show the user that the item is active. The listeners and attributes go on the DOM element to capture drag events and maintain accessibility. This component is reusable and fully self-contained. The draggable component is now functional. When you hover over the item, you should see it respond to your cursor. When you click and drag, the opacity drops to 0.5, giving visual feedback that you're actively dragging. The useDraggable hook automatically adds all necessary event listeners and ARIA attributes, so your draggable items are accessible out of the box. The transform is applied smoothly, so the item follows your mouse without jank. The component registers itself with the dnd context, so the context knows about this item and can coordinate with other draggables and droppables. If the item isn't responding to your drag attempts, check that it's properly wrapped in dnd context. Now let's create a droppable container component. The useDroppable hook is your tool here. It marks an area as a valid drop target. It returns setNodeRef to register the DOM node and is over to know when something is hovering over this zone. We apply visual feedback. The background changes to green and the border becomes solid when something is over the container. This instant visual feedback is crucial for good UX. Users need to know that the item will land in this container. The container renders its title and all items currently inside it. Notice how we're separating concerns. The container manages the drop zone, while individual draggable items handle their own drag behavior. This modular approach makes your code clean and maintainable. The droppable container is now active and waiting for items. When a draggable item enters the container's area, the isOver state becomes true, and the styling updates immediately to show a green background with a solid border. This gives users clear visual feedback that they're in a valid drop zone. When they move the item out, isOver becomes false and the styling reverts. The container communicates with dnd context, so the context knows which items are over which containers at all times. You can have multiple containers, and they all work independently. The beautiful thing about this architecture is that containers don't care which specific item is over them. They just know that something is hovering. This decoupling makes your code flexible and easy to extend. Now we bring everything together. The handle drag-end callback is triggered when the user releases a draggable item. It receives the active item and the over container from the event. If there's no valid drop target, we return early. Otherwise, we find which container the item came from and which container it's dropping into. If they're different, we update state. Remove the item from the source container and add it to the destination container. This is your core drag-and-drop logic. We maintain items as an object where each key is a container ID and each value is an array of items. When dnd context fires the onDragEnd event, we process the move and update state. React then re-renders with the new arrangement. This approach is clean, scalable, and easy to extend with additional features like sorting or persistence. When you drag an item and release it over a container, the handle drag-end function springs into action. The event contains the active item being dragged and the over container where it's being dropped. We extract this information and locate the source and target containers. If they're different, we perform a state update that removes the item from one container and adds it to another. React detects the state change and re-renders the components, causing the item to appear in its new location. This is the fundamental pattern for drag and drop. Detect the drag end, identify source and target, update state, and let React handle the re-render. Simple, performant, and battle-tested. Here's a real-world Kanban board application using everything we've learned. The board has 3 columns: to do, in progress, and done. Each column is a droppable container, and each task is a draggable item. Users can drag tasks between columns to update their status. The handle drag-end function moves tasks from one column to another by updating state. The example includes realistic tasks like design UI mockups and implement auth. Notice how the column headers are automatically generated from the column IDs. This Kanban board pattern is used in production applications by teams worldwide. You can extend it by adding animations, editing capabilities, persistence to a backend, or filtering by assignee. The core drag-and-drop logic remains the same. Let me share some common pitfalls and how to avoid them. First, don't manage drag states scattered across components. Use dnd context to centralize it. This makes debugging easier and prevents state sync issues. Second, updating state on every drag move event will tank your performance. Only update state when the drag ends. Third, forgetting set node ref on droppable elements means the drop zone won't register with dnd context. Always attach it and ensure your ref is properly set. Fourth, avoid expensive calculations inside transform handlers. Use CSS. Translate from the utilities package, which uses GPU-accelerated transforms and maintains 60 frames per second. Following these practices will result in smooth, performant, and maintainable drag-and-drop experiences. Here's a quick knowledge check. When you use the useDroppable hook, it returns setNodeRef. What does this actually do? SetNodeRef is crucial. It registers your DOM node with dnd context so that the context knows this element exists and should be considered as a drop target. Without it, your droppable container is invisible to the drag-and-drop system. The ref gives dnd context access to the node's position, size, and other layout information necessary for collision detection. This is why forgetting setNodeRef is such a common mistake. Always attach it to the element you want to be droppable. Another important question. When should you update your component state? The answer is only on drag end. If you update state on every drag move, you'll trigger a re-render every pixel the user moves their mouse, which is terrible for performance. Instead, let the hooks manage visual feedback. Is dragging and is over come directly from the hooks and update instantly without state. Only when the user releases the mouse should you update your persistent application state. This separation keeps your drag interactions smooth while ensuring your data is updated correctly. How does dnd-kit achieve smooth 60 frames per second dragging? It's all about transforms. Instead of moving elements by changing top or left properties, which cause layout recalculations, dnd-kit uses CSS transforms. Transforms are GPU accelerated, meaning the browser can move elements without recalculating the entire layout. This is why we use CSS. Translate dot to string from the utilities package. Additionally, dnd-kit separates visual feedback from application state. The hook provides is dragging and is over immediately, while state updates only happen on drag end. This architecture keeps your drag interactions smooth even on slower devices. You've now mastered the essentials of dnd-kit. Let's recap the key takeaways. dnd-kit is the modern choice for React drag and drop because it's lightweight, fully accessible, and completely flexible. You wrap your app in dnd context. Use useDraggable for elements you want to drag, and useDroppable for drop zones. Always remember setNodeRef. It's the bridge between your UI and the drag and drop system. Update state only on drag end to keep animation smooth. Use CSS. Translate for transforms, separating visual feedback from application state. The library handles accessibility automatically, so your interfaces are usable by everyone. The architecture is modular and scales from simple lists to complex board layouts. Start with simple examples and gradually build towards more sophisticated interactions. Thank you for watching Elevate Learn, and happy dragging!